Spectral and Polarization Vision, Spectro-polarimetric Real-World Dataset. Large image datasets have driven the success of data-driven research in computer vision. However, they rely solely on RGB intensities, simulating human-level vision perception and understanding. But what about natural vision? Have you ever imagined seeing beyond simple RGB data? Animals in harsh environments with limited brain capacity often rely on visual systems that extend beyond simple RGB data. They utilize unique wave properties of light, such as spectrum and polarization. The spectrum refers to the range of wavelengths of electromagnetic radiation. We can classify color imaging into RGB multispectral and hyperspectral based on the number of spectral bands. Even if two images have the same RGB intensities, they can have different hyperspectral distributions, providing much more information. Polarization refers to the orientation of the electric field as light travels through space, which can be described by projecting the electric field to a plane tangent to the light direction. Polarization state of light can be described as a full-dimensional vector called Stokes vector. S0 represents the total intensity, and S1, S2, S3 represent the intensity difference between the two types of polarization. So we aim to provide a spectro-polarimetric dataset. There are many existing spectro-polarimetric datasets, as you can see in this table. However, they typically suffer from limited object, scene, and illumination diversity. Also, they contain primarily linear polarization information and offer a small number of images. Our datasets overcome these limitations by providing the full Stokes vector, images across 21 channels, and more than 2,300 scenes with labeled real-world images. We introduced two types of data set I mentioned before, trichromatic and hyperspectral Stokes dataset. We captured various real-world objects and scenes in diverse environments. As shown in the statistics of our dataset, we cover indoor and outdoor settings, different times of capture day, and various illumination conditions. To acquire the trichromatic Stokes dataset, we used a single-shot camera, incorporating uncensored quarter wave plates, and linear polarizers. This setup allows for the single-shot capture of trichromatic Stokes images. Consequently, we provide full Stokes images, including S0, S1, S2, and S3 for RGB3 channels. To acquire the hyperspectral dataset, we utilized an imaging system with rotating quarter wave plates and a liquid crystal tuner filter, allowing us to capture images across 21 spectral channels sequentially. As a result, we provide full Stokes images including S0, S1, S2, and S3 for 21 hyperspectral channels. We conducted several analyses on our spectro-polarimetric datasets, including denoising spectro-polarimetric images, Stokes vector and gradient distributions, spectral dependency of chevron polarization, environment dependency, memory-efficient representation, and comparison of polarized and unpolarized light. Our dataset, containing large first Stokes data and captured in diverse environments, enables this intuitive analysis of the real world. We believe other vision applications and analysis can be achieved using our datasets. Our work provides a foundation for future research in spectral polarimetric imaging and vision. So if you're interested in our work, please visit our project webpage through this QR code. Thank you.